Okay, welcome to lesson 9. This is the quotient rule. So in the last lesson we talked about how to take the derivative of products. So now we're going to talk about how to take the derivative of quotients. So up at the top here I'm going to talk about the product rule. So I'm going to give you the product rule again. So the product rule is f times g is f prime g plus f g prime. But the quotient rule, and a lot of times books will give you and other teachers will tell you that the product rule is f g prime plus f prime g, which is perfectly legit. That's perfectly fine. But I always give it to you this way. The reason being is the quotient rule. So the quotient rule has to be stated this way. F over g is, the derivative of that has to be f prime g minus f g prime, because over g squared, because it has to be stated that way because of the subtraction sign. All right? Now again, if you go back to my pyramid, then what you get is if you're multiplying, you add. If you're dividing, you subtract. And that's just a way to remember what operator is going in the middle right here. Okay? But the order for both of these in my method stays the same. All right, so let's get to some examples. So for this one, I want to simplify my answer. And I'm going to find that y prime, using the quotient rule, so I'm going to use a quotient rule. And again, I will always state the quotient rule so that I learn the quotient rule by the end of the examples. So it's f prime g minus f g prime over g squared, where f is 4x plus 8, so f prime is 4, and g is 6x minus 1, where g prime is 6. Okay? So now to find y prime, I simply have 4 times 6x minus 1 minus 6, and I'm going to just write the 6 first because 2 times 3 is the same as 3 times 2, over 4x minus plus 8. All over the denominator squared, that should have been a squared, denominator squared, which is 6x minus 1. Now, do not multiply the denominator out unless you just feel like doing that, but you don't have to. Now I'm going to distribute, so that's 24x minus 4 minus 24x minus 48, all over 6x minus 1 squared. So when I simplify this again, I get that y prime equals negative 52 over 6x minus 1 squared. And we're done. That's all there is to simplifying that thing. Okay, for number 2, I get something a little more complicated. All right? So again, my quotient rule is f over g prime equals f prime g minus f g prime over g squared. So this gives me that f is 7x squared plus 14x plus 7, where f prime equals 14x plus 14 over g, where g is 2x plus 2, so g prime is 2. So what I find is that dy dx equals f prime is 14x plus 14 times 2x plus 2 minus f is 7x squared plus 14x plus 7 times 2 all over 2x plus 2 squared and that should have a parentheses around it. So I get that dy dx equals, I'm going to factor out a 14 here, so I get x plus 1, and I'm going to factor out a 2, so I get x plus 1, minus, and this factors into minus 7 times x plus 1 squared times 2 all over 2 times x plus 1 squared. So what I have, because I have to simplify, dy dx. Now, in the numerator, I can factor out a 7 times 2 times x plus 1 squared, and I'm left with a 2 minus 1. Okay? So I have an x plus 1, x plus 1, x plus 1. Okay? A 2 and a 2. And here I have a 7 and a 7. And all of this has been factored out. So that leaves a 1. And all that's left here is a 2 from the 14. All right? All over 2 squared is 4 times x plus 1 squared. Okay, so this equals, the 4 cancels here and leaves a 2, and these cancel here and they go bye-bye. So I'm left with a 7 over 2, and 2 minus 1 is 1, so this leaves 7 halves. All right, so there's that one. So that's one method using the product rule. I also want you to note that if I had my original, so I had y equals 7x squared plus 14x plus 7 over 2x plus 2. So that equals 7 times x squared plus 2x plus 1 over 2 times x plus 1. So that equals 7 times x plus 1 times x plus 1 over 2x plus 1. So those cancel. So what I really have is I have 7 halves times x plus 1. So y equals 7 halves x plus 7 halves. So then dy dx equals 7 halves. So I could have simplified this before I started and not done the quotient rule. Just a thought, just another way to look at it. Okay? Now, from now on, we are not going to be simplifying our answers. Yay! But we are going, for some of these, having to do some multiplication to start with, or we're going to have to be doing some product rule, excuse me, to make our derivatives a little bit easier to take. So I could do this one in 2 methods. So method 1 is to leave it alone, so that I have the quotient rule. So I have quotient rule. So I have f over g prime equals f prime g minus f g prime over g squared, where f equals x plus 4 times x plus 1. Well, in order to take this derivative, I have to use the product rule. So I have pq prime, so that's p prime q plus pq prime, where p equals x plus 4 and p prime equals 1, and q equals x plus 1 and q prime equals 1. So that tells me that f prime equals, so it's right over here, f prime equals 1 times x plus 1 plus 1, well, that's right, x plus 4 times 1, okay? And then I have g equals 4x minus 1, so g prime equals 4. So that makes dy dx equal to f prime is 1 times x plus 1 plus x plus 4 times 1 times 4x minus 1 minus x plus 4 times x plus 1 times 4 all over 4x minus 1 squared. And this is perfectly good answer. Okay? Or, so that's method 1, or I could do where I multiply f out. All right? So I'm still using the quotient rule, but f equals so then f prime equals 2x plus 5, and g equals 4x minus 1, and g prime equals 4. So then I get dy dx equals 2x plus 5 times 4x minus 1 minus 4 times x squared plus 5x plus 4 all over 4x minus 1 squared. Either one of these answers is a perfectly good answer, and I would accept either one. Okay? So either one of those is perfectly good. Okay? Now, for number 4, what I would suggest you do is I would suggest that you would take either x minus 7 times x minus 4 and get x squared minus 11x plus 28, or you go the step further and say that x squared minus 11x plus 28 times x minus 1 and go all the way out and get x cubed minus 12x squared plus 39x minus 28. And if it were me, I would probably go all the way out just because I find the derivative of polynomials easier. So then I would do the quotient rule. Where f is 3x minus 1 and f prime is 3 and g is x cubed minus 12x squared plus 39x minus 28, and g prime is 3x squared minus 24x plus 39. So then dy dx equals 3 times x cubed minus 12x squared plus 39x minus 28 minus 3x minus 1 times 3x squared minus 24x plus 39 all over x cubed minus 12x squared plus 39x minus 28 squared. And that is a great answer. Okay, but you don't have to multiply it out. You could do the product rule twice. You could just multiply the first one out and do the product rule once. Okay, and on a key for an exam, I would have multiple answers. Okay, now for this one, we're going to take the derivative and then we're going to apply the value at 2. So, quotient rule. F prime g minus f g prime over g squared. F is 5x squared minus 3x. F prime equals 10x minus 3. G is 3x plus 4. So g prime is 3. So then what we get is we get 10x minus 3 times 3x plus 4 minus 5x squared minus 3x times 3 all over 3x plus 4 squared. All of this evaluated at x equals negative 2. This equals 10 times negative 2 minus 3 okay, so 10 times negative 2 minus 3 times 3 times negative 2 plus 4 minus 5 times negative 2 squared minus 3 times negative 2 times 3 all over 3 times negative 2 plus 4 squared, which equals negative 20 minus 3, negative 6 plus 4, minus 5 times 4 minus plus 6 times 3 over minus 6 plus 4 squared equals negative 23 times negative 2 minus 26 times 3 over negative 2 squared equals negative 32 over 4 equals negative 8. Okay? Find the equation of the tangent line at the given point. So the first thing we need to do is find the point. So that's f of negative 1. So that's 3 times negative 1 over negative 1 plus 4. So that's negative 3 over 3, so that's negative 1. So we have the point negative 1, negative 1. Second is find the derivative. So that's f prime of x equals, and so that's the quotient rule. So that's f over g prime. So that's f prime g minus fg prime over g squared. So f equals 3x, so f prime equals 3, g equals x plus 4, so g prime equals 1. So this will be 3 times x plus 4 minus 3x times 1, all over x plus 4 squared. Third is find the slope, which equals f prime of negative 1, which equals 3 times negative 1 plus 4 minus 3 times negative 1, the 1 doesn't matter, over negative 1 plus 4 squared, which equals 3 times 3 plus 3 over 3 squared. So m equals 3 times 3 is 9, 9 plus 3 over 9. 9 plus 3 is 12 over 9, which equals 4/3. So I have m equals 4/3. I have the point negative 1, negative 1, and I have y equals mx plus b. So I have negative 1 equals 4/3 times negative 1 plus b. So that means that I have negative 1 equals negative 4/3 plus b. So I have negative 3/3 plus 4/3 equals b. So 1/3 equals b. So my tangent line is y equals 4/3 x plus 1/3. Alrighty. Now let's find the normal line. So first we find the point. G of 2 equals 2 squared plus 2 times 2 over 3 times 2 plus 5. So that's 4 plus 4 over 6 plus 5. So that's 8 over 11. So that gives me the point 2 times 2, not 2 times, the point 2 8/11ths. Second, I need to find the derivative. So that means g prime of x. I need to use the quotient rule, which is f over g prime, which is f prime g minus f g prime over g squared. So f equals x squared plus 2x. So f prime equals 2x plus 2. And g equals 3x plus 5. So g prime equals 3. It's my sidebar. So g prime of x equals 2x plus 2 times 3x plus 5 minus x squared plus 2x times 3 all over 3x plus 5 squared. 3, I need to find my slope, which is my derivative at 2. So this equals 2 times 2 plus 2 times 3 times 2 plus 5 minus 2 squared plus 2 times 2 times 3 all over 3 times 2 plus 5 squared. So my slope equals 6 plus 5 squared is my denominator. So that's 4 plus 2, 6 plus 5, minus 4 plus 4 times 3. So my slope equals 6 times 11 minus 8 times 3 over 11 squared. So that's 66 minus 24 over 121. So that is 42 over 121. This is my tangent line. My tangent line. So then my normal line is -1 over m because it's a perpendicular to the tangent. So that makes it -121 over 42. So that means for 4, I have a slope of -121 over 42, a point of 8 over 11, and y equals mx plus b. So that means I have 8 over 11 equals -121 over 42 times 2 plus b. So that gives me 8 over 11 equals -121 over 21 plus b, which is 168 plus 1331 over 11 times 21 equals b. So that's 1499 over 231 equals b. So my normal line is y equals -121 over 42x plus 1499 over 231. Okay? Please email me if you have any questions.